Hi, I'm Aaron Wilson, OSU Extension climatologist, here to talk about temperature inversions. When it comes to considering appropriate weather conditions under which to apply herbicides and pesticides, one of the most challenging weather conditions to contend with, besides windy conditions, are temperature inversions. What are temperature inversions, and why is it important to recognize them? Under typical weather conditions, air temperature decreases with increasing height away from the surface, at least throughout the bottom layer of the atmosphere, called the troposphere. Sunrise in the morning initiates vertical motion in the atmosphere that builds into the afternoon, leaving the surface warmer than the air above it. We often see puffy white cumulus clouds because of this. Now later in the afternoon, as the sun starts to set, the surface cools very rapidly, leaving the surface air cooler than the air above it, and this is a temperature inversion. This temperature inversion will continue to strengthen throughout the night as long as there are clear skies and light winds, and then start to break down again 1 to 2 hours after sunrise the next morning. So why is this important? Well, once temperature inversions are present, there's no longer vertical mixing in the bottom layer of the atmosphere close to the ground. That means air moves horizontally along the contours of the land, seeking the lowest elevation possible. Since winds are light in the evening, it would seem like a good time to spray. However, temperature inversions leave spray droplets suspended above the ground surface in that cooler, denser air, and they're able to move horizontally onto neighboring fields and off target. Also, under high temperatures, dicamba and 2,4-D can volatilize, becoming a gas, suspended in the atmosphere and then ultimately carried by the inversion conditions. So some conditions to keep in mind. Inversions prefer light winds. Strong evening and overnight winds will limit the formation of inversions. Clouds present will also impede or slow the formation of inversions and prevent the surface from cooling too quickly. The conditions under which dew forms, dew is a good sign that an inversion exists, and as the surface continues to cool, fog is a sure sign that the inversion has existed for a while and is continuing to strengthen. Now remember that air above a closed canopy will form an inversion earlier in the day, so it's a good thing to keep in mind. Also, any areas behind windbreaks or wind shelters will allow those inversions to remain much longer during the morning. And if all else fails, take a look at the weather map. High pressure on a weather map is a good sign that the inversion will form that evening and continue throughout the upcoming night.